Hey guys, my name is Jordan and welcome to Chillin' with My Ohmies. I am glad to see you here in my first video. I'm trying these TikTok, YouTube thing for the first time. Thing is, I have been building high voltage projects for over 10 years now. I've got myself a collection that keeps on growing, and I keep getting comments from people online or from friends that I should really do some YouTube or TikTok or some work for what I've built and what I continue to build. So this channel is going to be dedicated to that, dedicated to the projects I've built, dedicated to the projects the other ohmies you'll meet later have built, and high voltage education. Something you should definitely know though is high voltage is nothing to joke around with or play around with lightly. Something you have to understand when you get into high voltage projects and working around high voltage is this could be the way that you die. Not a ha ha ha, this could be lethal. You need to understand that, yes, if no matter how smart I am, no matter how careful I am, no matter how good of a person I am, no matter if I have a family or not, electricity doesn't care. High voltage, you make one bad mistake one time, you're dead. I came really close to that with a microwave oven transformer about 10 years ago, as I will get on here about at another time. But before we get into it, a little bit about myself. Again, my name is Jordan. I work in the aerospace industry for a defense contractor on things we will not talk about any further. And my original education with high voltage comes from someone you probably already know, Chris Bowden. I worked with Chris in person many times. I was a volunteer at the Geek group that he ran in Grand Rapids. You know, the one where he got shut down by the IRS and ended up going to the clink for. He was still running that operation. I got to learn about high voltage there. I was 18, 19 years old at the time, and it really stirred a fire in me to start building my own projects. And I have so many projects now, and I have so much to share that I might as well just start a page. So we'll get into it. High voltage. So first off, what is voltage? Voltage is energy over charge. Then is the formula for high voltage, energy in joules over charge in coulombs. And you can think of voltage more in easier terms as electrical pressure. What it is the difference of charges. So think of it, if you're familiar with PSI, pounds per square inch. Think of it as that. It's pressure, but instead of air pressure, instead of water pressure, it is electrical pressure. So, for some examples, most phones have a 5-volt battery. That's 5 volts. 5 volts has absolutely no danger to a human being. The lithium-ion battery, however, the chemical reactions, if you puncture it, that's another story. But 5 volts, that's not even close to high voltage. 12 volts. Your car battery is 12 volts. Is that dangerous to you? No. The reason is, yes, they can put out tons of current. And what kills you? The current. That is correct. But you can only put out current if you have low resistance. So we go to this formula. It's Ohm's law, my favorite law. V over, and we'll do this little triangle here, current and resistance. So if we take this law here, and we have 12 volts over the resistance of the human body, could be anywhere from 100,000 to a few million ohms, but we'll give it the easiest chance, 100,000. 100,000 ohms. So 12 volts divided by 100,000 ohms, that is, if I do the math in my head, 0.0000012 amps. Which, if you put that in engineering notation, that's 120. Again, I just did the math quick. I'm not good at quick math, so don't get me wrong, but that's 120. This would be it would be 12. So 1, 2, 3 milli, 1, 2, 3 micro. So it'd be 12 microamps. To kill a human being, you generally, the lowest current you need to kill a person is passing 100 milliamps through the heart. That 12 microamps is many orders of magnitude less than the 100 milliamps that's needed to kill a human being. So a 12 volt car battery, not going to hurt you electrically. The chemicals inside, on the other hand, those can get dangerous, or of course if you drop the thing on your foot. If your skin is wet, say you have wet skin and you cross the terminals, you might get a little buzz as the current runs through the water. But a 12 volt car battery, even though it's capable of hundreds, even thousands of amps, will not hurt the human body because of this equation, V over R equals I, and 12 volt car battery over the lowest resistance you would see in a human body, 100,000 ohms, not dangerous. So now that we got that out of the way, let's talk about some other voltages. So if you live in the United States and Canada, you have 120 volt. 120 volts in your wall. 120 volts, not particularly lethal either. It hurts really bad. Believe me, it hurts bad. But it doesn't, still 120 over 100,000, that just moves it to 120 micro when we need 100 milli for a lethal shock. Now, if you have the right situation where you are holding on to, so you're in the bathtub, you're surrounded by water, especially tap water, which has minerals in it, making it more conductive, and you're in that bathtub and you reach over, you grab a hairdryer, you pull the wire out of the wall, you get hit. Yeah, you could die from that. That has happened. But other than in those really rare circumstances, the 120 on your wall, not going to kill you. It's going to hurt, not going to kill you. 240. So most U.S. houses have 240 volts for appliances such as your dryer or your air conditioner. And most Europeans have 240 as a standard wall outlet. Again, not really in the, oh, it's going to kill you range. However, we're going up to 240 micro. So we're getting closer and closer to lethal. So it would be very rare exceptions that will kill you. Most factories here in the U.S., I'm not sure about over in Europe, use 480 volt three-phase. That is, again, you're getting higher current across the human body, but kill you? Maybe, maybe not. It's not a guaranteed death sentence. According to the medical community, not the electronics community, not the industrial, but according to the medical community, 600 volts, I'll write that down here as we're running out of space, 600, according to the medical community, that is high voltage. So 600 volts is where a doctor will go, okay, we need to get you in the hospital right now to get your heart checked out. Less than that, they probably will still check you out. But that 600 and above is the red flag for doctors, here in the U.S. at least. What I'm dealing with, in my experiments, my lowest voltage supply is a microwave oven transformer. You may have heard of these things. They are lethal. They are dangerous. I got shocked by one. It went through my right finger, down the right side of my body, out into a fridge. I was sitting on a fridge, and it burned a hole in my pants and a hole in my finger. That is an uncurrent limited, roughly 2,000 volt transformer. Don't go ripping those out of your microwaves unless you understand the risk. If that current would have went through the left side of my body, through my heart, I would have died. And that's not a oh, look, I almost died. That's a serious, if I was using the other hand, I would have been killed. And let me tell you, even though it went through the right side of my body, missed my heart, and it was not lethal, it was one of the worst pains I've experienced in my whole life. It's a non-current limited 2,000 volt supply. And then we'll get up to other things I have. So for my Tesla coil, which I'll show you in multiple upcoming videos, I'm using five, if you can see that, neon sign transformers. Neon signs use high voltage to operate. These 5 neon sign transformers They are 15,000 volts each, 15,000. They are limited to 30 milliamps though through an internal shunt. A shunt is a way to limit current on a higher voltage supply. However, I have all 5 of them in parallel. So when you put supplies in parallel, you don't increase their voltage, but you do increase the amount of current they can dish out. So 5 times 30 milliamps, that's 150 milliamps out of, when they're chained together in parallel. 15,000 volts, 150 milliamps, death sentence, right? But that's not the highest I go. Then I have my big Jacobs ladder, James. He has a potential transformer that's 14.4 thousand volts. That is also uncurrent limited. That is also, I actually made a ballast, an inductive ballast to current limit it, but even then, it is very much lethal, and you'll see that in an upcoming video. Another project I have is Jimmy, my mini Jacobs ladder. He was my first high voltage project. He runs around 20,000 volts. He's safe, and let me explain why. Jimmy is current, though 20,000 volts, is highly current limited with an inductive ballast. Inductive ballast is a way for an AC circuit to limit current but not voltage, because you're using non-real power or reactive power. So you're able to limit your voltage, limit your current without limiting your voltage. Jimmy is built in that way. And Jimmy has such low current that it's ballasted at, that you can touch the 20,000 volts and be fine. You're thinking, what? How can that be true? If I put 20,000 up here and 100,000 here, I should get, what, 2 amps through my body? Well, the thing is, in a current limited supply, once you start drawing too much current, more current than it's rated at, the voltage tanks. So when you get shocked by Jimmy, you're not getting shocked by the 20,000 volts. The second that current starts going through your body, the 20,000 volts drops way down in order to satisfy this equation. This equation is power equals current times voltage. If you have, let's say 10 watts of power, that's all the power you have. You have 10 volts. We'll just make this simple here. And you have, that means you can have up to 1 amp of current. If you try to draw more than 1 amp of current, that means this, so you try to draw 2 amps, now you're at 20 watts. Well, if you don't have a 20 watt power supply, did you just break the law of physics? No, you didn't. Because what will happen if you draw 2 amps from the supply, only have 10 watts from it, the laws of physics will correct this, and voltage will come down to 5 volts. So that's how Jimmy, though at 20,000 volts with no load, the load of a human body will bring it down to a safe voltage. So is it the voltage or the current that kills? The answer is yes, both. You have to have enough power to maintain enough voltage to drive enough current through your body. It's not volts kill, it's not amps kill. Enough enough power to maintain enough voltage to drive enough current through your body using these 2 equations. Now, let's get back to some of my projects. On the top end of things, on my nuclear fuser, I have a Farnsworth Hirsch nuclear fuser in my basement. It's almost done. I will post videos of that soon. But anyways, that uses high voltage, and I have a X-ray generator. It's an it's a transformer for an X-ray machine that takes 240 volts from the wall AC, pumps it up with a step up, and then uses an enormous high voltage diode to turn that AC into DC for X-ray machines. I actually got that one off Chris Bowden when the Geek Group went under. That one goes up at full power input, 240 volts in. That will go up to 70,000 volts out. I have it current limited, but not current limited enough to not be lethal to the human body. 70,000 volts, little current limiting, It's taken about 40 amps in. 40 amps in at full power. 240 at 40 amps, multiply those, do the math, and you'll find out that if I was to touch that output when it was on, that's the end of me, that's the end of my channel, that's the end of my bloodline, I'm done. So that's definitely my most dangerous, but I have more dangerous. And then the last thing I want to talk about high voltage is my Tesla coil, Tony. You see, Tony, he takes the 15,000 volts, we take the 120 volts from the wall, use the neon sign transformers to make him 15,000 volts, and then, since the Tesla coil is basically just a resonant transformer, invented by Nikola Tesla, of course, it brings that up to, you can't really measure it because there's no tools to measure voltages this high, at least reliably or cheaply, but the highest voltage it will go up to, you calculate by the length of arc. I'm getting about a 4-foot arc, or streamer, what it's called when it's not contacting anything. I'm getting about a 4-foot streamer off of Tony, and that indicates I'm running at roughly 400,000 volts. So getting close to 500,000 volts, and you're thinking, well, oh, that's definitely lethal. No, it's not. And the reason is we go back to the P equals IV equation. Power into Tony, the Tesla coil, is 2250 watts maximum. Well, 2250 watts, and then we get the voltage of 120 volts, and we get 18.5 amps, I think it is, if I remember right. That is then stepped up to 15,000 volts at 150 milliamps. Primary, that is lethal. But once it gets stepped up again to the 400,000 volts, you step up voltage, current has to step down. You step down voltage, current steps up. So the current coming out of Tony the Tesla coil is almost nothing. It's enough to put on a lightning show. It's enough to have 400,000 volts in my garage. But if I was to give it the load of a human body, say 100,000 ohms, the voltage would tank down to just like 100 volts or less. So it's perfectly safe to touch electrically, but not heat. So the plasma streamers coming off of a Tesla coil, those are incredibly hot. And while it's not like lethal or anything, it will burn your fingers, your hands, or anything that touches. However, the 400,000 volts from Tony's the Tesla coil is not lethal, so to say, electrically. So that's actually safe to touch, other than the burning, but I still want to touch it because I don't want to get burned, and it just feels wrong touching a 4-foot bolt of lightning with your bare hands. So there's a breakdown of what high voltage is, what projects I have built that I'm going to show you, what projects I might plan on, and how you can learn more about high voltage projects, and just the crazy stuff you can do with high voltage and energy. I have other projects. I have some flash capacitors that can put out 20 kilojoules. I have some other capacitors where me and Dr. Dreadman, the other person on this channel, are going to be building a railgun. So stay tuned. There's plenty of cool videos to come. Lots of education, lots of sparks, lots of booms. It's going to be a fun time. Thank you for watching. I hope to see you all soon.